All right, so chapter 2 review. Like I was trying to tell you, I think this is relatively simple. A couple of proofs might be a little tougher, but let's take a look at the first problems here. It says, explain how the figure illustrates that each statement is true, then state the postulate that can be used to show that each statement is true. It says, first of all, that planes J and K intersect at line M. All right, two planes always intersect to form a what?
Line.
To form a line. All right, so what do we have? What's the solution? Two planes meet at line L, or two planes meet on the line M. If two planes intersect, then our intersection is a line. All right, is everybody okay with that? All right, definitely B. All right, anybody have any questions with that? All right, now again, listen, we have a lot to do. All right, so I'd like to try to go through as quickly as we possibly can. Chance, are you okay? Here we go. Well, while that's doing that, just listen carefully then. All right. Number 2, the intersection of two planes contains at least 2 points. All right. Why is that true? Because
2 points form a line.
2 points form a line.
And when 2 planes intersect, they form a line.
Yeah, so always.
Always.
Yeah. Now, again, if you recall that every line has what?
2 points.
At least 2 points.
Yeah, they
All
can
right.
have more.
Right. Most definitely. All right. Now let's look at question number 3. It says in the figure, line M and ray TQ lie in plane A. State the postulate that can be used to show that each statement is true. Point L and T and line M lie in the same plane. What are you thinking? If 2 points lie in a plane, then the entire line containing those points lies in the plane.
Yeah.
All right. Now again, think it through, please. All right. That's the important part. All right. If the points are in the plane, then the line containing those points must be in the plane also. Everybody agree with that? All right. So now, let's look at 4. In the figure, E is the midpoint of AB and CD. All right, so here's our first little proof here. All right, so let's see if we can do this. All right, now, if E is the midpoint of AB, then I would like for you to mark that as true. All right. And then if E is the midpoint of CD, then what? I would mark them exactly. All right. Now it also says that what? It also says that AB, right? That AB is congruent to what? CD. Now I think it's logically that you can conclude that obviously all 4 of those segments are now congruent, but obviously we're going to prove that. All right. Now again, for the 2-column proof, let's go ahead and start this out. Statement and your reasons. All right. The first thing I would say is yes. Now, number 1, given. All right, we have it drawn, so that's fine. All right, now the next important thing, all right, is to use the information. All right, and again, there's several orders here that you could use, so it doesn't matter how you're seeing it, but what could you say right off the bat? That's exactly correct. All right, so we now can say that A, E, is congruent to EB, and CE is congruent to ED. Is everybody with me on this? Right? And then we could just simply say that that is the definition of midpoint. All right, now let's look at 3. What could we say also now from there? Yes, sir.
I did AE plus BB, AB, and C.
That's exactly correct. And what is that?
Segment addition.
Yeah, the segment addition postulate. All right. So I want everybody to be able to tell me that AE plus EB equals AB, and CE plus ED equals CD, and that is the segment addition postulate. All right, do I have any questions for that?
What's the difference between the midpoint theorem and the definition of midpoint?
I think
Doesn't matter.
I don't know. I'm not. Right. Did you write the midpoint theorem?
No, I didn't, but I tried to study like the terms last
Yeah.
night, and I got it.
Yeah. I would never. Okay. Here we go. So now that I have that, what will be the next statement? Go ahead. Good for you. Very good. Very good. Very good. AE plus EB is equal to CE plus ED, and that's good. Substitution. Right? Is everybody okay with that? Because why? What's true about A, B, and C, D? They're equal, correct? Everybody with me? Because they're equal, their equals are equal. Right? Okay, now here's where you want to be careful, because you want to look at the proof. I'm trying to prove that AE is congruent to ED, right? So I need to get rid of what? EB and CE. Think about that. That's how I like to look at the proofs. See what you have and where you're going. So what else could I do on this now? Yeah. What? I don't think so. I don't think so. Why can we say AE is congruent to ED?
No, EB.
EB is what?
I'm saying AE equals EB because that's 2AE equals, and then you'd say CE equals EB.
But I need the next step though.
Okay.
So what would the next? You're right.
Definition of
No. You're right. But how would I write? I need to.
AE equals.
No. Tell her.
AE plus AE.
That's exactly right. AE plus AE is equal to what? ED plus ED. Right? Yes.
Can't you just switch?
No, because we don't have. Yeah, you're
Oh, yeah.
you with me? So again, that is also what?
Substitute.
Yeah, that's a substitution also. All right. Now for 6, you would say what? 2AE is equal to 2ED. Yeah, we can simplify that. Now we can do what?
Let me divide.
I think you would divide, right?
Why can't you just
So we would say AE is equal to ED, correct? And that is division, property of equality.
And we don't have to do the correct thing.
Now, again, here's where I'm looking at. You know what I'm saying? Just, again, I'm not, because I have equal here and I have congruent here, I would know that the last step could be what? They're congruent by definition of what? Congruence. All right? So step 8, I would like for you to say AE is congruent to ED. But if for some strange reason you left that off, I would just tell you to be careful All right. Is everybody with me on that? All right. Again, you always look at the prove what you're trying to prove. We have equals all the way through. All right. So I would want you to see that you're just supposed to say the last step 8 is definition of congruence. Everybody okay with that? I don't think that's that hard now. All right. I really don't think it's that hard. All right. Look it over. All right. Make sure you can do it on your own. All right. Now let's take a look at question number 5. Again, writing a 2-column proof to verify each conjecture. So here's what we got. Statement and reasons. So again, we would just say number 1 is the given. Now, step 2. Somebody go ahead, fill me in. Step 2. Go ahead.
3x minus 5 plus x plus 1 over 2. And that'll be the definition.
No, wait a minute now. What are we just doing on that, buddy?
Or no, substitution.
Yeah, substitution, right. Is everybody good with that?
Why wouldn't you put the angle addition before?
Actually, that's not a bad thought.
ABC plus CED.
Because honestly, listen to me right here. They give you this information. They tell you that that's true. You see what I'm saying, right? Now, if I was trying to make it a little bit more complicated, I guess we could leave that.
No, that's fine.
You know what I'm saying?
Yeah.
You for that, I think the step before that is not a bad thought, but they're giving you that information, so it's just really a direct substitution. All right, and so number 2 we could just say is what is given. I'm sorry, that's why I said substitution. All right. Now the next step right here. Yes.
It's 6x minus 10 plus x plus 1 equals 180.
Yeah.
Multiplication.
Yeah, I like that.
Wait.
All right. Well, we'll just watch. Remember now, all you're doing is just look what's up on the board and see what's different. All right? That's all I'm asking you to do. All right? Step 3, she said, was 6x minus 10 plus x plus 1 equals 180. So your job is to try to now figure out how she got that.
Oh,
What do we, yes, the multiplication property of equality. Yep. Multiplication property of equality. All right. And now the next thing we're doing is what?
Simplify.
Yeah, I would just say simplify. Some geometry books use combining like terms. All right. Doesn't make a bit of difference to me. All right. And now we say what? 7x is equal to, and that would be addition property of equality. All right. And so now for final step, x is equal to what? X is equal to 27. Division. Yeah, I don't Okay, now let's continue on. All right. Refer to the figure. Dan knows that the distance from Grayson to Apex is the same as the distance from Reading to Pine Bluff. So from so far. Hold on a minute. The distance from Grayson to is the same as this from Reading to Pine Bluff, so I moved that over. All right, this is a nice little proof too. Which is obvious, right? So we want to prove that from Grayson to Reading is the same as. Is everybody okay with that? All right. Very, very simple. All right, but let's practice real quick. Here we go. Statement, reason. All right, so in this situation, number one, we could just say the given. All right, number two, somebody help me out. Come on. Segment addition postulate, which would say what? I'm sure. Go ahead.
And then GA plus AR is equal to AR plus RB.
But isn't that what aren't we trying to prove? We don't know that GR is equal to AP yet. Right? So what am I doing?
So GA plus AR is equal to AR plus. Oh.
That's what I'm saying.
We're trying to prove it.
Yeah. So somebody tell me what's something else.
You can subtract
Um.
Now are we supposed to do like that?
you subtract
How am I?
Oh, never mind.
You have to do the what are you looking for?
Oh, I know.
GR. We have to do like the
GA plus AR equals
yeah.
AR.
That thing.
GA plus what?
AR equals
AR plus RP? That's what she said. Yeah, no. That's honestly that's what we're trying to prove.
No, are you supposed to get like the GR? No.
Now, so again, someone even said we did this already. So what do we got, guys? Come on.
GA is equal to
Look, so we have to use that information. GA is equal to RP. So that means wherever I see a.
Oh, yeah, that's what I was looking for.
Right.
So wherever you could put an RP.
Wherever you can do it one of two ways. You can say wherever I see a GA, I can put what? RP.
whoever sees it.
No. We don't want to do that. And watch. So if this GA, listen to me, if that GA becomes what? RP, right? So now RP plus AR equals GR, and that's a what? That's a substitution. Come on, guys. Does everybody see that? Now look what we have. All right, now I have AR plus RP here, and I have AR plus RP here. Do you agree with that? Does everybody see that?
Oh, so your GA plus AR. Because then you can just do GR equals AP.
Now we can say that GR is equal to AP. GR is equal to AP. And that's, again, just a what now? That's a substitution. All right. Now, again, I'm looking at that. That was a little bit different. Does everybody see now how obvious that is, correct? Which parts?
Between two. So you substituted
I changed GA to what?
RP.
Exactly.
Okay. I thought
Right.
you were using the second one.
Everybody see that now? Anybody else? Everybody good? That's it. All right, next. Okay, so in this case, what do we have? What are 1 and 2 called?
I got this
Ankles.
Linear pairs.
They're linear pairs, correct?
4x.
And if they're linear pairs, that means they're automatically what? Supplementary,
Yeah.
right? So now let's just solve it out. So we say 4x plus what?
28
Equals 180. Now I kind of want to guys get you in this habit. Look right here. I would like for you to identify or just observe that all of those are divisible by 4. Do you agree?
Yeah.
So I would like it to make it even easier. X plus 7 is equal to 45. So X is what?
38.
X is 38.
So it has to be A.
Is everybody okay with that? So if X is 38,
Has to be it.
then angle 1 would equal 48. All right. All right. Now, question number 8. Those are called what type of angles? Those are called vertical angles, and vertical angles are what?
Equal to
Perpendicular.
So 7x minus 24 is equal to 5x plus 14. So we have 2x is equal to 38. So if we say x is 19,
Plug it back
yep, plug it back in.
in. 109.
Wait, why'd you do any math? They have to equal the same thing if they're vertical angles.
Yeah, it's 109.
Like, why'd you have to do any math?
Yeah, you know what? She's actually correct on that.
Because it could be. I don't like math. I just don't.
Reagan, it could have been if you wanted to.
No.
It could not have been perpendicular.
You're wrong.
Well, I mean, you're right, but if you were just
But
looking
no,
off of,
it's
it's
not.
the same number.
Hey, just listen to what she's saying. I agree. There isn't anything there. If they were perpendicular, they both could be 90. But there is no indication that that is necessarily true. All right. So I would conclude that the answer would have to be A. However, all right, I would have done the work anyway just to verify the information. All right, I would have done the work to verify the information. All right. So number 5. So make a conjecture about the next term in the sequence. Looks like we're just doing what? Subtracting 5. All right. So again, be careful. Don't put minus 5 down by accident. All right. The answer would be what? 67. Subtracting 5. All right. Now, what do we know is true if we make a conjecture? If M is the midpoint of BC,
BM equals
there we go. If A plus B is less than or equal to 8, and A equals 2, then B is less than or equal to 5. All right. So listen. If A is 2, that means 2 plus B has to be less than or equal to 8. So B has to be less than or equal to what?
5. So just be.
Now, the counter answer, the counter example is which one proves that that statement is false?
B.
Right? So it says here B must be less than or equal to 6. Up here it's saying that it has to be less than or equal to 5. So B could be what?
5.
What? Where are you getting B is less than or equal to 6?
I don't know what
Where are you getting
But
that?
when,
Okay, so let me just clarify that. It's saying that A is equal to 2, right?
Yes.
So I plug 2 in
Oh,
for A.
it's less than 6.
right? And then I just solved that equation. That equation tells me that b has to be less than or equal to 6. The problem says b has to be less than or equal to 5. So to prove that that statement is false, you could let b equal what? 6. All right, that would be the counterexample to show that that is a false statement. All right? The hypothesis is what? All right. And then the conclusion would be then x equals 1. All right. Now, yes, x plus 4 is equal to 5. All right. Converse. To do the converse, what are we doing?
If not, P.
Wait a minute.
Don't bark.
It's just the
Cat.
opposite. That's contrapositive.
Cat thing flying.
The inverse is when you just negate them.
Well, you think of like the purple moon or something, then it has to
No.
be.
We're just switching them. We're just switching.
Ducks will fart and cats fly.
I
It's
don't even want to know what dogs do with this problem.
if ducks bark, then cats fly. That would be the converse. All right. 14. All right. The inverse. All right. Now the inverse is the one that you're going to negate. So you would say if a triangle has 3 equal sides, then it is equilateral. If a triangle does not have 3 equal sides, then it is not equilateral. All right. That's the inverse. All right. Now, it says, which best describes the statement a plane contains at least 3 points not on the same line? Always true. Very good. All right. What time's the bell ringing? You guys, is that what
15. Oh, wait, no, that's
I think 9/11.
9/11?
Is it 9/11 or 9/13?
Okay. We just got a few minutes in.
9/7.
Okay. So here, listen. So I've also come to something else I think I'm going to do is instead of giving you another review tomorrow, I think what I'm going to end up doing is just I'm probably going to just accept all this work, because there's so many problems here, as kind of your quiz. All right. So I think that's perfectly fair. All right. Now listen, you guys, you gotta hear me out too.